Good morning, good day, good afternoon, good night. Welcome to the Bitaxe Townhall. I'm One Clue, your host, and I'm really happy to be here and to have a conversation with you about everything all around the open source miners United community and especially open source Bitcoin mining. Today, we do have the Townhall number 44, which is an insane accomplishment that we achieved here. Like, this Townhall is happening usually bi-weekly, and not always is it happening, but in, I'd say, 97% of the time it is. So I'm really happy that it is happening again and that we guys can have a conversation. Before we do start in any topics whatsoever today, I want to make sure that everybody in the audience does know if you have any questions or if you want to talk about some specific topic, feel free to do so. You do have the Town Hall chat, which you can use to type out your questions if you do have some. And if you want to come up on stage and just have a chat with me in voice, you can also do that this way. But be sure everything that's happening in the voice will be recorded and later on uploaded. So far so good. I think we have a couple of topics to talk about. First things first, what the heck's going on? This week was so damn busy. I was probably able to boot up my PC twice over the course of this week, and I just checked out the ESP Miner repo again. There are so many pull requests. This is insane, like literally. I don't know what happened there, but plenty of people are doing plenty of things as usual. Some that are always doing some nice work there, but there are really nice features that are in there. I was trying to clean up a couple of these already, marking them, giving them a couple of tags and what you can do on GitHub, and trying to sort on what I need to do or need to review this weekend. So today is Saturday, probably nothing gets reviewed today, but tomorrow is Sunday, so I should have a little bit of time to actually do that. And there are really some nice new design changes and some other features that are probably going to be introduced in this and going to be shipped to the next version. So currently we're sitting at the version 2.10.0, and yeah, I mean, things are mostly stable. You do have the usual things of like people complaining that you don't get enough hash rate or that the device is running too hard, but well, neither of them can be fixed by us unless you want to change the frequency. We cannot magically give you more hash rate. But hash rate is a good topic because there is probably something technical I need to talk with you about, which we need to do and probably do later on in this town hall. I just need to remind myself about that. Let me quickly give me a second. Here we go. So I just wrote it down so that I do not forget about that. Yeah. Apart from that, there are plenty of new things that are coming for the next release, the release 2.11.0. Currently, we do not have any anticipated date for that. I assume it will be mid to end next month. So you do see releases are now slowing down. In particular, is this really important for the reason being that people don't get confused by too many updates too often. And I think the current approach that we do have, the last two releases, they were happening sort of monthly, maybe 2 monthly or bi-monthly. So yeah, that was working really great. We had lots of time to actually go over all the changes and check out what's going on, what kind of features we want to implement, and what should be moved back or given back to the PR initiator for rework and stuff like this. So there are plenty of things that are happening. One thing that is probably the most interesting to some of you is the initialization for the next Bitaxe, the Bitaxe Naja, which currently is a PR that I have put into the milestone for the version 2.11.0, but to be fair with you guys, I think this will not happen very soon. And the first reason for that is, if you don't know what the Bitaxe Naja is, it's basically the next Bitmain chip. It's called the BM1340. And this is the chip of the S23 Hydro. So this is a complete new chip family. There is also another new chip, which is the BM1372. But on that, I think we haven't done any engineering so far. So there are two new chips. But the Bitaxe Naja will use the BM1340. It will use two of them. And Scott has managed to get conversation with them, but the initialization is not really working out like it should be, because we're missing bits and pieces, and for that we need a couple of things. One of these things is obviously that we get our hands on one of these nice new control boards with the new firmware for these specific chips. And unless we do that, it is a little bit guessing in the wilderness, or however you want to call that. It's not really that possible or feasible to figure it out. I mean, you could, it's a trial and error process, but it will take a really long time. So the easiest way would be to just wait for these new control boards, new hash boards to come out, which will happen in 2026 in January, if I'm not mistaken, maybe even in December. And then we can just hook them up to the logic analyzer tools that we already do have. And yeah, just give them a quick glimpse of what we want to record of them. And then we can see what kind of initialization we need, what kind of commands we need to send over to all these chips. And then we should be able to actually use them. But unless that is happening, we don't really have a 100% working unit there. The initialization for the Bitaxe Naja or the init Bitaxe Naja support, it's a rather small PR, I'd say. There are obviously 11 file changes, but most of them are just like, well, let's add the BM1340 to this whole instance, which is a lot of copy and paste and changing a couple bits and pieces and trying some things out on it. But yeah, again, it's not fully working, and the chips that we do have, we don't know if they're actually genuine or not, or if they are faulty or not. As far as I do know, it was a really, really weird thing to get these chips over to Scott and let him play around with that. So yeah, the current state of the next Bitaxe Naja is on waiting or on pause, or however you want to call it. I mean, sure, we would be able to just hook it up and test out plenty of things, but is that feasible? It probably will cost months or weeks, probably weeks to months, and then you don't even have the chips available, so it doesn't really make sense to work it out yet. The best way would be to just wait, and then we can figure out the proper way how to initialize these chips, and then you can right away get them, because you can purchase these new hash boards, you can desolder the ASIC chips and just use them in the next Bitaxe. It's the approach that's currently been used. Some manufacturers somehow managed to get their hands on brand new chips out of the factory, which is also a nice thing. And we don't know when this will happen to the next chip. So yeah, that's going to be an interesting one. But if you do take a look on the history, we've seen the BM1370 coming out, and it took over a year before anybody ever had brand new chips out of the factory in their hands. So yeah, probably we're not going to see that. And why I'm even talking about this is a rather specific reason. And the reason being is, like, if you use chips that are brand new out of the factory, they have never seen too much temperature, they have never seen any solder or anything else. So they are basically like a blank canvas, and you can do whatever you want with them. They're beautiful. They don't have anything that would disrupt their being. But if you take yourself a fully assembled hash board, you rip off these chips and then you try to clean them and resolder them, you put on stress on these chips. And we've seen that depending on how careful you are with these chips or how careful you're not are with these chips, it will affect plenty of things. The temperature, the hash rate, what's on. So it could be totally possible that you purchase yourself one Bitaxe of manufacturer X, and then you decide, well, I need another Bitaxe because they're freaking cool, and now you purchase it from another manufacturer Y, and out of a sudden, both of them do have different performances. Like everything's the same. Let's even say the PCB is with the same ounce of copper and so on. There could be total big differences. Sure, we are also talking about silicon lottery in these dies. Like the chip itself can have a difference from chip to chip, but also on how you do handle them, which is really important to notice because, yeah, everything can be different in these chips. They are really sturdy, and I'd say they do have some sort of a degree what they can resist on temperatures and everything else, especially in the process of not utilizing them but just soldering them. But even that, we've seen their degradation in performances all over the board, over all of these chips, if you solder and resolder them too often. Even one time soldering and desoldering can impact that, which is rather interesting, I think. So the next thing that we probably should talk about is the hash rate. I mean, I've said we cannot magically give you more hash rate, but what we can do is to give you the most accurate hash rate reading. And PMax, my shout out goes over to you, because I was looking through a couple of lines of codes that he was producing, and also with that, my shout out goes over to CTCR, who was originally pushing them. And yeah, there's one thing I want to talk about. There's currently nothing going on with that on GitHub, and there's a reason being for that, because on my end, I'm still testing. I'm still trying to figure out a couple of bits and pieces. PMax is already working on something for probably his next release. But the hash rate and how we do calculate that can be tremendously different to what you actually want to do. So let's just talk about the BM1370, the Bitaxe Gamma chip, if you want to call it like that. There are registers, and you can think about that like you do have this chip, and this chip does have plenty of different pins that you can connect to. One of the nice things is each of these things usually does different things. We have something for voltage coming in, we have something for voltage going out, we have some different communication pins, and then we do have also, I want to abstract it like that. I do know it's not 100% correct, but I just do it that way. We have some pins that you can use to modify or configure certain things on these ASIC chips. You need to do that for one reason, to actually give the chip instructions on like, dude, you need to do that, and you need to do these calculations, please. So you need to tell it that. But you need a specific pin that you connect to, and you can send over these commands so that the chip itself knows on what to do. There are also other pins that you can use to read out things. One of these things is, for example, the temperature. We can read out the temperature directly from the BM1370, even though it's kind of weird state, because there is a diode in the ASIC chip itself. So technically speaking, we can use this diode and read the temperature, and we are already doing that on the Bitaxe Gamma. Previously, on the BM1366, there was no such diode in the ASIC chip. So what we did, we needed to have a different component on the board, on the PCB, that was trying to match or be as accurate as possible when it comes to the temperature of the chip. And yeah, we did that with the MC2101, but with the BM1368 and with the BM1370, we do have diodes that we can use for reading out more accurate temperature. At least that is what we're trying to do. And I think we're really close to the actual temperature of everything, so this is totally fine. So we have a pin that we can use for reading out the temperature. We also do have basically a register or a pin that we can use. I do know I'm mixing up here a couple of these terms, but I just try to do it in a way so that everybody gets it, what I'm trying to say here. So there are other pins that you can use to read out other parts of the chip. And in the chip itself are basically spaces or smaller boxes that you can call registers. And depending on in which register you are, you can read out or modify or initialize different things. And someone figured out, CTCR figured out, that there is a way to read out the hash rate directly from the chip, from the count register, if you want to call it like that. PMax was also working on certain other things that are really crazy and that I still need to dig in. But this one, I think, is rather important to get right, because the current approach that we do have, if you think about hash rate, is, and CTCL, I think he was putting out the right term for that. It's a luck-based hash rate calculation, which is a rather interesting approach that we took, but it is the most feasible, and that I'm not saying it's not accurate. It's just a way that you usually should not do when it comes to having multiple chips, or that you could do it even then, but yeah, it's probably just peeking around and seeing how can we get even more accurate, how can we even get like really close to the actual hash rate that this chip is producing. And the current approach is basically, you do give your chip instructions. You tell it, well, init please. Then after a while, you send over some jobs. A job is basically a prepared package from the ESP32 that does have some instructions of, well, hey, here is some work, take this input, do something with it. And because in the initialization part, we already told the chip on what it's capable of or what it needs to do, it doesn't know what to do with the input. So it doesn't know what its job is. Basically, you do have one employee, you give it a pickaxe, and you tell it, well, your job is to use this pickaxe on, I don't know, coal. And after a while, you come back and you throw some coal in front of your employee, and hopefully he's starting to work on that. So that's what a job is. You just give it a job with a little bit of things to do. What the ASIC chip will do is it will create nonces, which are basically some sort of answers that you can use later on and put them back together to create a share. And let's just skip over to the part where we do give back this nonce to the ESP, and the ESP does some magic stuff there. And as soon as it did that, and the answer of the ASIC chip is above a certain threshold, we can send out and submit a share to the pool. So now we do have a submit. And let's say we just hit 100 million of a minimum threshold of 4K or something like that. This submit will very likely get accepted and will be counted on the pool side. And here comes the interesting part. So the current implementation on how we do calculate the hash rate on the chip itself is based on how often and how frequent we do produce these answers. And initially you think, yeah, well, that must be totally correct. And it definitely is. Like the hash rate that you do see on the Bitaxe or even on the NerdQX or any other NerdX device, it's not wrong. I'm not saying that it's wrong. It's probably very close. But as far as my understanding currently, and I still need to dig into that a little bit more deeper, is we can read out a more accurate hash rate out of the chip itself, which does have a register that we can use, that we can read out over a certain period of time. We can do some magic calculation on the back end as well, and then we can spill out some new hash rate or more accurate hash rate. So we're just talking about like changing the way of how we do actually calculate the hash rate, because there's one thing. If the ASIC chip does produce errors, but is still working more or less in a optimal way, I'm not talking about a perfect way, it's like more or less working okay. It will produce errors, probably. Sometimes it's worse because, I don't know, the chip is broken or parts are not really working correctly or one or two cores are destroyed inside of it. Then you do have some answers of this chip that are not correct, that are producing errors. And if I'm not mistaken, in my current understanding, and PMax, please, I do know they are in here, please correct me if I'm wrong about that, but these errors are not calculated properly into the hash rate calculation. So if you do have them, it could be that they get into the hash rate and will be accounted to that, which can be eliminated if we do use the register, because the register does have way more potential. It does have multiple information files that we can use. We can even see how many errors and what kind of errors we do see over certain changes when it comes to how we interact with the chip itself, which is rather interesting in my opinion. So the whole reason why I'm talking about this is the hash rate that you do see on your devices is okay. Nothing is wrong there. It is just fundamentally how should we calculate the hash rate should be changed probably. And again, as I said, PMax being a legend over there with all the Nodix devices, he made already some changes on his firmware, and he's testing out plenty of things over there. And yeah, I'm trying my best to porting things and changing things as well for the Bitaxe. So we'll see how long this will take. Maybe I can play around with that tomorrow again. But yeah, it's a rather interesting thing. Like, I thought we were at a state of like, all right, everything is pretty good. We are settled into this. We know so much, and then it's crazy. Like, I was reading back the messages of CTCR, who was originally posting about that, and to my own embarrassment, I'm not always following all the messages all over around. He sent those, if I'm not mistaken, in February or May. So yeah, oops. Yeah, but I mean, again, the device itself is working properly. Otherwise, you would see different hash rate on your device than on the pool. Like, you would have major differences. Obviously, the pool always does have a difference, especially if you mine on something like NPool or Ocean or what else, then you will only see your hash rate accumulated over a period of time if you submit shares, because the pool can only know if you submit shares. But your device that you do have at home, you have the option to actually talk to the chip and ask it, hey, well, dude, how quickly are you currently working on that? And please give me some number. Yeah, and PMax is writing in the chat, one advantage is you have a more correct hash rate around 20 seconds after reboot. No ramping up, no lag, no crazy jumps. Yeah, that is definitely a thing. And I believe people were not really disappointed about the fact that the ramp up hash rate was incorrect. I think some of them like that, but yeah, you're totally correct about that. The initialization is like, you haven't submitted any answers, and now you're submitting so many answers in such a short period of time. Oh my goodness, your hash rate needs to be that. So now you see one of these issues. Like, if you have too many answers in the beginning of like working on a job, it appears to be that your hash rate is like 2, 3, 4 terahash on your Bitaxe, while it is not. So yeah, one advantage of just talking to the chip itself and asking it, like, dude, please, here's a counter, count up if you do this or that, and after a certain amount of time, I will read it out, I will clear it, and I'll try to calculate something on top of it, and then you can read out the actual hash rate that you do have on the chip base level on a really, really accurate thing. You're not working on luck, because it could be that once you boot up your Bitaxe, so let's take 2 Bitaxe, one on the left, one on the right. The left one is booting up and it's producing 20 jobs instant, or 20 answers instantly. The right one is booting up and it's only producing 5 answers instantly. So who do you think does have the better Bitaxe with the better chip? From what you do see on your dashboard, or if you do log the hash rate via your console, you think the left one is the better one because it's way better. But it was only luck, because we are still trying to search in a nonce space. So with Bitcoin blocks, I'm just trying to go around here and make sure that everybody does get it where we're talking about. So if you're trying to find the next Bitcoin block, you do have spaces where these chips are searching in. And basically, with our jobs that we are giving to these chips, to our employees, We give them some specifications of where to search and what else. And yeah, it could be that one of these trips is just having luck and finding plenty of answers in a certain space, while the other trip is working on a completely different space and doesn't have that much luck. So you would assume that the left one is way better, but it's not. Both of them are equally. So yeah, that's the magic here, why we should change it. And probably 99.99% of the people will never ever notice this. Like, you don't even see that there's a difference happening on the hash rate calculation, but it should be done for the sake of OCD or other things. Yeah, it's rather interesting. It's rather interesting. And Bitcoinite is writing one thing that is particularly correct. This could be helpful for improving the self-test. The self-test that we do have is usually not really interesting for anybody who is purchasing a Bitaxe and just firing up. You just want your device to be working. But the self-test was initially designed for manufacturers, and it should be reworked. And I think I do have an issue open for that. If not, I should create another one, because I do know I have done 1 or 2 issues about the self-test. There are a couple of bits and pieces that we need to adjust about it, because the current way is, yeah, it's okay, it's working, but it's not really helpful in actually determining what could be wrong with your device or what's else. Maybe we could even transform the self-test over to something that would give users, in the end, the ability to actually check the device. Let's say something broke on your device and you don't know what's happening. Maybe you do have some necks or anything else going on in your I2C lines. Well, if you do have these, we can't help you, because then nothing will work. But apart from that, the self-test could be improved to give some debugging functionalities or give some information on the display. Let's say, I don't know, like the device is booting up and you're going into self-test as a user, you see if the chip is available or not. You see we could do some hash rate calculation, especially with some pre-assembled work that we can give it. We do have in the current self-test one function that is basically sending a old Bitcoin block to, or a old job to the AC chip, which was for a very old Bitcoin block. And we just try to calculate the hash rate. And if the hash rate is in a certain range, we assume the chip is okay. But here you see the issue. It could be luck-based, right? So even the manufacturer may have an issue if they are not properly testing their devices. So if we can use the correct hash rate out of the register of the AC chip itself, man, we can eliminate a lot of issues, which is fantastic in my opinion. So yeah, I think with that, let me quickly go over to Reddit. I love Reddit. Reddit is so damn crazy. I've asked the question on Reddit about what are your most common issues, which was so funny. Like, I was reading it, I was like, oh my goodness. Is this actually happening? Like, a couple of people were responding, not that many. The first and best issue that most of the people have ever experienced is like, it hasn't found a block yet. Like, what the heck is going on? Please give your Bitaxe a small, tiny, gentle slap and try to push it over the finish line so that you do find a block. But yeah, no, jokes aside, I think one of the most best comments in my opinion was like, I don't have any issues. They work great. Fantastic. But obviously always there's something happening. So yeah, we had someone on Reddit who was posting Wi-Fi module as a issue. And I was asking, can you specify this? Can you elaborate a little bit more about this topic? I haven't received an answer, so I don't know if there are actually any issues on that. If you do guys ever experience any issues, feel free to comment them or send them right now in the town hall chat. And for everybody who's listening later on, comment them down below. I think this video will go on, or this town hall will go on YouTube and what else? Podcast everywhere, yada yada. So yeah, the last thing is the heating issues. I think initially I talked about that. Like, we cannot fix your hash rate. We cannot fix your heating issues. This is one of this. Like, we cannot fix it. Heating issues are in so many different categories. One of the things is you might have a bad heatsink. You might have bad thermal paste. So the paste between the chip and your heatsink is maybe bad, or it's not even there. Or you use some plastic, I don't know, could be. So yeah, it's always worth to figure out a little bit of what kind of device do I have in front of me. If anybody of you is ever deciding to purchase yourself a new Bitaxe and you want to go for the Bitaxe Gamma, and now you do see this nice advertisement somewhere online and you find the Bitaxe Gamma with this tiny 40 by 40 10 millimeter high yellow, black, orange heatsink, don't do it. Don't do it. This tiny heatsink is not made for actually cooling down such a component. The chip itself, I mean, we've tested it. Technically speaking, you can push this tiny chip up to 40 watts. But I guarantee you will not be able, even in the default settings, to use your Bitaxe properly if you live in a Mediterranean environment and you do have from time to time between 20 to 25 degrees Celsius. I don't know what this is in Fahrenheit. I'm sorry for my American people over there. I don't speak that language. But yeah, nah, that's not a good idea. Don't use these tiny heat sinks. They are not designed for removing that much heat off of a component like this. Don't do that. So, Pollock is running the chat. Really new to the space, hope to learn and get better things for the sessions. Is the hash rate shown always higher than the actual efficiency of the machine, or does it also go the other way? Whereas sometimes the hash rate is actually higher than what's shown by the machine. So that's the thing. I haven't tested the register, so I cannot tell the difference between the register answers and the hash rate that we do get from the current approach that we take for calculating the hash rate. But the current approach of like calculating the hash rate based on the jobs or the answers that we do get from these jobs is working properly. It's correct. The only issue with that is it's luck based. So it could be one time on this particular job, you have tremendous amount of luck and you find many, many answers in a really short period of time. It would look like you do have really, really more hash rate. While in this particular case, the register of the ASIC chip would probably tell you, wait a minute, your hash rate is still 1.2 terahash on stock settings. So yeah, in that particular case, it could be that the hash rate is not accurate. But how can you eliminate this issue, if you want to call it like that, in the current state of form? You just activate the statistics on your web page of your Bitaxe, because then you do see a nice overview of an average over a certain amount of hours. So if you just create an average over, let's say, 2 to 5 hours, we have a more accurate reading. It's not 100% accurate, but yeah, well, then it should be more accurate than what you do see, because sometimes you do have these spikes going up and down, up and down. It's also happening on the chip itself. So even if we read out the register, there are spikes. Sometimes the hash rate is a little bit higher. It's capable of calculating things quicker. Sometimes it's not. So everything on that end is totally fine. Fluctuation of hash rate is usual. That you do see like a device sticking to a particular hash rate, that is unusual, at least for the current moment. And that's also a thing, like if you think about, for example, these big machines from Antminer, they tend to usually show you the expected hash rate and mix that sometimes with the actual hash rate. So that's kind of a weird thing, a weird approach of showing the hash rate to the user. But it's not inaccurate, to be honest, if everything is working properly. If you do have a hardware fault, then probably things are off. But when it comes to the efficiency, one particular issue that we do have with the efficiency of these devices is what can we calculate when it comes to the efficiency? Well, we can basically calculate everything apart from the ESP32 and the fan. Maybe on some of these boards, maybe even the display. But you do get the point. There are components on this PCB that are not calculated into the efficiency factor. So if you take a look on the dashboard and you see, well, I do hash at, for the simplicity, let's just use 1 terahash. We hash at 1 terahash and we do have a wattage draw of 20 watts on the dashboard. I guarantee you this reading is incorrect because it's not accounting for the fan, it's not accounting for the ESP32 and a couple of other components that are on it. Why is that? The reason being here is the energy basically flows in through the barrel connector that we currently do have from the Bitaxes, and then the future ones, this will change over to the XT30 and other XT input connectors. But anyway, so energy is flowing in. It's going in a couple of directions. And one of these directions is into a so-called TPS 546, which is a buck converter or step-down converter. It is taking energy and it's changing it to a lower frequency, to a lower voltage. Not frequency, just to a lower voltage, so that the AC chip can operate. So the AC chip for the Bitaxe Gamma does operate on a voltage of 1.2 volts-ish. The recommended voltage for it is a little bit lower, so we're not really at 1.2 volts, but for simplicity, we just use that. What is happening on the software that we do run on the ESP32 is we do have a straight communication line over to this component who is converting 5 volts coming in down to the 1.2 volts, and we can tell it, well, whatever you use, tell me what kind of amperage you do put out or what kind of amperage you get in, so that I know how much power I use. But what we're not accounting for is everything that is in front of this component, because we can't. We could, but we don't. And how could we? We could put a INA260 or any other component that's capable of doing that. We could even use a shunt to measure the actual power draw, an accurate power draw of the entire board. But still then, we will be off by 5 to 7% probably, because the power supplies that you do use, that you plug into your power wall outlet, they also do have a percentage of loss. And depending on what kind of manufacturer you do go for, or what kind of standard it does use, it could be different. But if you think about PCs, if you've ever built yourself a PC and putting in a CPU, GPU, and so on, you do have the PSU, and sometimes they do have ratings. 80 gold, 80 bronze, 80 platinum, I don't know what else ratings are out there. But the higher the rating, it always is at like 80 and then something. 80 bronze is really bad, silver, gold, platinum. I don't know if titanium or something like that exists. But the higher the rating is, the better the efficiency is of these power supplies. The INA260 is end of life. OMG. I'm still using it, and there's something coming out which is also using it, so probably, yeah, the INA260 is end of life. PMAX, man, that's really sad to hear. So we should probably play around a little bit with shunts. I mean, you did so. PMAX already did. So playing around with shunts is definitely a thing that should be done. Yeah. Xbox is also talking about fast burger brains. That's 100 Fahrenheit. So 100 Fahrenheit is 25, 30 degree-ish. That's good to know. Anyway, I think this gives a little bit of a brief understanding about how the efficiency and hash rate can be different from what's actually happening. We cannot account for any losses on the power supply that are happening because of inefficiency of the power supply itself. With the current design of the Bitaxe, we can also not measure everything else that is not running through the TPS. And through the TPS is basically only running the AC chip. A couple of other things as well, but yeah, basically only the AC chip. And we're just measuring that. What we did to account for that in a 10%-ish, okay-ish range, I'd say, is we put up some magic numbers and we just add them to the number that we're reading. And what kind of magic numbers I'm talking about? What we did is like, we built these boards, we plug them in, and we have like 20, 30 boards, different power supplies and what else. We write down the numbers that we do get at the exact same hash rate or at the exact same settings, and then we calculate basically a median about that, and this one got added to the board itself. So if I'm not mistaken, it's 7 watts for the gamma, it's 5 watts for the super or so. So yeah, it's just a magic number that we're adding to the actual reading that we can get from the TPS, because we cannot account for everything else. And there's also the thing, like if you spin your fan lower, it's totally different. If you spin it higher, it's totally different. If you run it really hot, your efficiency goes into ass. So, yeah. At what percentage of efficiency loss would you consider changing your ASIC chip? So the ASIC chip itself obviously does have a really, really high efficiency loss. Basically, everything that the ASIC chip is doing is directly converting over to heat. Like it's producing, I don't know, 99.9% heat. You put in 100 watts, you get out 100 watts of power in heat. That's probably I do know what you're trying to ask, but the efficiency loss on the ASIC itself is not really the issue. The issue itself is sometimes these chips can get broken. They are wearing out because people are running them way too hot, or what else. And what is too hot? Well, everything that is above 65 degrees Celsius is way too hot. And yeah, that's one of the issues. If you don't treat this device like something you want to clean from time to time, you probably create yourself a couple of issues. So that's rather important to think about. Let's say you do have an ASIC chip, and now we are going into the category of what kind of efficiency loss do we have with it. If you do have two chips side by side and you're trying to measure them, and one is hashing at a efficiency of 19 joules per terahash and the other one is at 23 joules per terahash, well, it's not bad. That is probably silicon lottery what's happening there, or bad cooling. But if the scenario is exactly the same cooler, same thermal paste, what else, then it is silicon lottery. And if it gets worse, then we're probably sitting into some wear out of the chip itself. Sorry, I quickly need to drink something. All right. Hopefully this answers the question. I do have a question for you guys. Maybe you can answer me that. I don't know if everybody of you just know that I do have this playlist on YouTube called Bitaxe 101, where from time to time, if I do have enough time for it, I try to create short, simple videos of explaining things to people about creating this open source miner, about how to develop on it, how to change things. And I'm sort of running out of ideas because I'm so used to it. It kind of feels like a sickness. I'm like, dude, I know this. Yeah, it's so hard to get myself into the position of what people actually do need. Like, because I do know all this shit. I know that we did certain changes to the firmware and where to find your new settings and everything else, but new people probably won't. So it's really hard for myself to get into that. I don't know, maybe some of you guys do have some good ideas about that. What would be needed? What is missing in parts of like questions that are arising with the device? Probably everybody who's listening to this right here in the audience right now is already familiar with the Bitaxe So it's also probably a really hard question for you because you know all of these things, or most of them. But yeah. Yeah, X. What's Bitaxe? Yeah, that's the very first video that I did about it. What's Bitaxe? And you want to know something cool? Okay, that's off topic. I got myself a new keyboard today. Totally weird. I'm switching topics here. It's called Lofree. Lofree. This thing is weird. Like, I love it because it's silent, and I hate it because the function keys are mixed, which is so weird. I don't know if I can change that. I purchased it because it was saying it's a German layout on the keyboard, but obviously it's not. What kind of piece of shit is that? I don't know. Yeah, just wanted to get that out here. Apart from that, as always, if you do have any questions, feel free to ask them in chat. And no, Duncan, it's not something China special. The second thing is, for everybody who's listening to this later on, if you want to know more about the Bitaxe project itself, check out bitaxe.org or go over to the website osmu.wiki. As well as if you want to know more about the community itself, there's osmu.xyz as well. Yeah, that's that. I think I'm done with the topics that I want to talk about today. I don't really have any more that would be feasible to put in the last 10 minutes. So I'm up for conversation about any kind of topics that you guys do have. If not, we will close up this session very soon. Speaking of the wiki, we should get some tutorials up there. True. Hex, that's really a good thing to talk about. So the wiki is one thing, but then I'm not sure if you were following the conversation about that the last time, but I'm still in the process of creating the bitaxe.helper page, which the idea is to create a new page where you can go to and hopefully get questions and answers to any kind of topic that you do have about the Bitaxe. That's the idea. The issue with that is it takes time. And I was even thinking about like creating videos for every single question that I could think of. And if any of these manufacturers is out there and want to help me, please just send me over an email with like the best 100 questions you ever received from your customers after purchasing a Bitaxe. That would be so helpful. Like with that, I could improve the wiki. I could improve the bitaxe.helper page. So far, not a single manufacturer has done so. So I'm left at the same position as before. It's an issue. It's the same issue that I do have with the Serious Bitaxe 101 because I'm used to it. I program on that stuff. And now I'm working on my own derivative of it, my own miner. Like, well, yeah, it's hard to think into the position of someone who is new to this. It's really hard because you don't think like, oh, you could think about this question. Like, what is an ASIC chip? Yeah, sure. That question probably can be answered in like 2 minutes. That's not an issue. That's going on these web pages, but I'm talking about like really, really specific things that I would never think about. Yeah. So that's one of the things that is happening. Wiki needs a little bit of love. So I'll make sure to put up some of these tutorials on the wiki in the next couple of days. Probably should fit in here or there, but most of them are usually tutorials or explanations. I don't know if that should go into the wiki. Some could, for example, about public pool, how to set up your own public pool. I think that's a fantastic tutorial for get started with getting on your own pool at home if you already do run a node. but most of the tutorials, I think they should go on the helper page, because they're more about like a specific question and here's the specific answer. Yeah, well, yeah, I still need a writer to help with that. Yes, I need a writer to help with that. Dude, that's the beauty and the bad thing about open source. Like, you're always demanding on others, because you know your day only has 24 hours. You need 8 to 9 hours at work. Then you come back home. So let's take off 2 more hours, because sometimes you drive a little bit more, you drive a little bit less. You're left with 14 hours of the day. People tell you that you need 6 to 8 hours of sleep. Well, you're left with 4 hours. Now into these 4 hours, you need to cramp in your wife, your children, and a little bit of coding and everything else. It's funny. It's working. It's working. But it's funny. So yeah. FAQ page would be perfect. Yeah, I hope so. The domain bitaxe.help is already purchased through a generous donator. So hopefully I should have something by next weekend, because next week I'm going to do a little bit of home office. So I should be able to do things simultaneously, because then I'm on my own PC. Yeah. Anyway, with that, I think we do not have any more questions about anything else. I thank everybody for tuning in here. It was fantastic being here and telling you a little bit about what's going on in the open source scene all around Bitaxe, and obviously Nerdex as well, because it's fantastic. Open Source Miners United is not gonna stop with what we're doing, and I do hope everybody of you is keeping up and hashing all day long. Till then, I thank everybody for tuning in today. I'm One Clue, your host. This was the Bitaxe Town Hall. Peace out and stay safe.